Is it possible to always make the better choice even when you don't have all the information? Imagine a simple game with two envelopes. One holds twice as much money as the other. You pick one, but just as you are about to celebrate, you are offered a chance to switch. Should you switch? Can math really guide you to the right decision, or does it only make things more confusing? This is envelope paradox, a puzzle that challenges our intuition and logic. And by the end of this video, it might just change the way you think about probability, decision making, and even life. Here's the setup: two envelopes, one choice. You don't know which has more money, but you pick one anyway. Now imagine you open it and find $100. Before you commit, you are given the option to switch. The other envelope might have $200, double your money, or just $50, half as much. What do you do? Stick or switch? Think about for a moment. Switching feels tempting, right? But can math really solve this paradox? To find out, we turn to something called expected value. Don't let the name intimidate you. It's simple and very useful. In fact, it's a tool people use every day to make smarter investments and financial decisions. Imagine a coin flip. If it lands heads, you win $2. If it lands tails, you win $1. Here's the question: on average, how much money should you expect to win from a single flip? Think of expected value as the average amount you would win if you played this game thousands of times. To calculate it, we multiply the value of each possible outcome by its chance of happening, then add those numbers together. So here's how it works. There's a 50% chance you will win $2 and 50% chances you will win $1. Multiply each value by its probability and add them up. This doesn't mean you will win $1.50 on a single flip. You will either win $2 or $1. But if you played this game thousands of times, the average payout per flip would be $1.50. That's expected value. Now let's bring this idea back to the two envelope problem. You have opened one envelope and found $100. If you switch, the other envelope could contain either $200 or $50, each with a 50% chance. So the expected value of switching is $125, more than $100 in your envelope. That's why math seems to suggest switching is the always the better choice. But there's a problem. The math isn't wrong, but the way we are using it. Here's why. We are treating the two envelope as if they are completely independent, like flipping a coin, but they are not. Here's the catch. If one envelope has X dollar, the other must have 2X dollar or X by $2. They are like two sides of a seesaw, completely dependent on each other. When we calculate expected value here, we are assuming each envelope could independently hold any amount of money. But that's not true. The value in one envelope depends entirely on the value in other. This creates a paradox. Math tells us to switch no matter what, but that's only because we have ignored the fact that both envelopes are linked. They are depend on each other. Once you have picked an envelope, switching doesn't change the odds. It just creates an illusion of choice. In life, just like with the paradox, our choices are often connected in ways we don't see, whether it's investments, risk, or everyday decision. Understanding these connections can make all the difference. And this is not only the paradox like it. Take the Monty Hall problem, another puzzle where intuition clashes with the reality. These challenges reveal just how much our assumptions shape the way we think. The envelope paradox shows us that math is powerful, but only when used in the right context. So, next time you are faced with a tricky decision, take a step back. Look for the hidden connections and don't let intuition lead you astray. This video made you think? Let me know in a comment section. And you can also click here for a telescope video. Click here for more cosmic colors. Thanks for watching.